Hi everyone, and welcome. Thanks so much for joining us today for the latest installment of FyneConf. It's really great to be back with you. It's fantastic to be back online talking about everything latest and greatest in the community. We've got a packed set of speakers this afternoon who are going to be talking about what's happening in the Fyne community, the latest technologies and best practices. Now, for anybody who's joining us for the first time, or a recap for folk who have been here before, I just wanted to take an opportunity to remind you about why we're here. And so the Fyne technology is all based on the vision that applications should no longer have to be operating system specific. You should be able to write them once, run them anywhere. This may sound familiar for how the web is ubiquitous and really took off for that reason, but it shouldn't be limited to documents and data transfer that way, but absolutely any piece of software that can be used. We're talking about no installers, no complicated instructions for how your software should be installed or distributed. It's just going to work. It's going to be drag and drop onto any computer in exactly the way that folk would expect to interact with it. And with the latest in technologies and development processes, we can throw out legacy problems of old, forget how thread management used to be a problem, memory management, and all sorts of challenging legacy items that still plague a lot of languages today. Actually, Go, the programming language, is a fantastic fit for this ambition, and it's why we picked it. So you're probably going to see a fair bit of Go code today. Hopefully that's not daunting to anybody who's new. And to old hands, hopefully we're putting it in idiomatic ways and it all seems familiar and easy to learn. But also, on top of that, we can make it trivial to build graphical applications in a way that it hasn't been before. They're going to be easy to get started, build what you're looking for, and they're going to look great out of the box. And as well as all of this, there's an opportunity to promote good engineering principles. The Go language has such great tools and processes, standards, documentation, and all of the things that make it easy to get up and running and building software that's going to be maintainable over time. And we're now finding ways that make it possible to do all of this with your graphical application development as well as the traditionally command line or cloud-based systems. And to put it simply in words from our website, our vision is to be the best toolkit for easily developing beautiful native graphical applications for desktop, the mobile, and beyond. So with that covered, it's been a phenomenally busy year, and I wanted to take an opportunity to tell you everything that is new. There's been a huge amount underway, and we're going to cover everything since the release of version 2.1.0 at FyneConf 1 year ago. So we have had 8 different releases of the library. There have been one major release, 7-point releases, and the version 2.3.0 that you might have been waiting for is really close now. We actually decided to extend it a little bit to get new contributions through Hacktoberfest, and so that will be arriving a little bit later on in November. Although that's not complete, since we last spoke to you, there have been over 7,000 commits from the community, people all around the world adding their contributions and fixes. And the project has increased in popularity according to the GitHub star ranking as well. We have 4,000 more stars than last time, and that red line showing the trajectory is looking very positive indeed. We have had over 25 new contributors in that time, and we're very thankful for every single person who is interested in helping out and being part of the project going forward. We also opened a Discord server, so thanks to the guys over there who encouraged us to be out in the wild outside of the Slack community. And we're also just starting to grow a group on Matrix as well, so hopefully we're reaching more people in socials. The number of applications that we have seen out there has increased by about 45%, so nearly doubled since last year. If you're interested, of course, there's the ever-growing list of open source applications at apps.fyne.io, but we're also seeing a large growth in production companies, so people who are using this for their consumer-facing software or internally for building their business-critical applications. And also we have the Fyne extensions repository, which has had some great additions this year, including a date picker, a new responsive layout, and a map widget. So if you're not familiar with that repository, I definitely recommend that you go and check that out after we're finished up here today. So like I said, we've had one major release has been out already. That's 2.2, which started the 2.2 branch of different releases. And we introduced in that release the system tray for desktop applications, delivering through a web browser for Fyne apps, which was a new and exciting addition. We also made it possible to define your themes through JSON, which made it a little bit easier for non-developers to start manipulating the look and feel of your applications. We added menu shortcuts, keyboard shortcuts for menus, which is adding to the richness of the overall menu experience for applications, and a host of new platforms, including OpenBSD, NetBSD, and also the iOS simulator. So now you can run iOS applications inside Apple's standard simulator on your desktop. And we also introduced an app metadata API. That and a few others I'll speak a little bit more about. And then we have the upcoming 2.3. There is a great new theme update that I will show you a little bit more that's coming as well. We're introducing the ability to synchronize cloud data for user preferences and file storage. It was mentioned towards the end of the event last year with a little teaser, and we've been able to deliver on all of those things. It's going to be great to show you what's possible there. We'll hear a lot more about the cloud capabilities later on. We're working also in improving the text handling for the engine that is displaying all of the textual elements in the user interface, widening the people that are actually going to get use of this right out of the box. I'll cover a little bit more about that. And we're introducing some more advanced application level containers and layouts, app skeleton for example, and a whole lot more that we're hoping to get squeezed into the release that is going to be arriving soon. Like I said, we've had real interest in the Hacktoberfest month, which we're not even halfway through. And so we're keen to see how all of that comes together for a release next month. But let's look at a couple of those things in a little bit more detail for people who aren't familiar perhaps with these features. So the system tray, like I said, this is for desktop applications. You've probably seen it around before. It supports macOS, Windows, and most Linux systems. So the macOS is what you see in the screenshot there. The Windows looks exactly like you would expect there. And the Linux is most systems because they do need to be running the modern spec, which is the dbus communication for App Indicator, but almost all desktop Linux is now running that. This is going to be working without any additional dependencies, so no need to bring in libraries or external tools to make this happen. And it uses familiar types inside the Fyne APIs. We use the same menu data type that you would use for your main menu or pop-up menus, and we're using resources for the icon. So it should all look very familiar. Let's just see a little bit of code that demonstrates that. So what you can see here, it starts with a type check that makes sure the running application is a desktop app. And so that will be true if you're running on a desktop application and not mobile. From there, we've got a cast of the application to a desktop version of the application, which we can use. We define a menu here, very simply, it's saying hello world. We add a menu item called hello. And when that is tapped, we'll print out system tray menu tapped. We just pass that menu into set system tray menu, which is going to set up everything. And no prizes for guessing, you can also set the tray icon, which is going to use a resource to set the icon that's going to be displayed. That line of code, that block of code is actually all that's used to display the screenshots you saw there. We automatically add a quit option for your application there as well, just like we do for main menus, where it fits the standard operating system lifecycle for an application. Let's talk a little bit about web browsers. So we now have a new target platform for Fyne builds called Web. Thanks so much to Cedric, who put a huge amount of work into making this possible. It's truly phenomenal what's been achieved. In fact, we're not only building one platform here, we're building both WASM and Gopher.js targets. If that doesn't mean anything, that's really not a problem. But it gives us the opportunity to pick the best runtime for your browser. we have discovered that we've been pushing their capabilities to the limits in some cases. And so by having both, we can pick one that's most likely going to work very well in the browser environment that it discovers when it boots up. You can deploy your builds to any web server essentially. We've noticed that some of them don't necessarily support the WASM file type out of the box, but a simple configuration tweak on your server there is all that's necessary to get it running. It's mostly happening in the browser. And in fact, if you don't want to deploy this to a remote server to see it working, you can just run FyneServe, which is a new command on the latest version of the Fyne command that will serve your application over the web. And so you can see in the screenshot here, you just connect to localhost on port 8080, and it's going to render your Fyne application. We see here the Notes app that you might have noticed from previous presentations running directly in the browser. Also, the metadata that I mentioned in passing was a chance to bring things together. We noticed a lot of people were looking for version information and others in their application. So primarily what we have done is taken the Fyne app markup file that you might remember from last year, which describes the metadata of your application for build. It allows you to avoid repeating parameters into the command line when you're making your builds and your packages. And we load this at build time so that it's available through the metadata function on the application type. And that's going to return an app metadata struct, which you can then interrogate using icon, name, version, and other field access to get information. So you can use this to know and present to your user the information that your application was built with, without relying on complex parameters or build scripts. Of course, mostly I'm excited to share with you the theme updates that we have been working on. So this screenshot here is showing the new theme for dark mode. You can see it's got lighter text, thinner input decorations, and overall a cleaner feel to the look and feel. We have at this time taken the opportunity to separate internal widget padding from the external padding between items for layout purposes. So actually you can do more now with your theme definition, and the items are going to be able to be spaced further apart without appearing larger internally. And this is the same in the light mode. There's slightly less change in light mode. The contrast was already quite good there. And it's a very pleasing mix, I think you'll agree, of the new definition of blues along with the lighter weighting of the elements around input controls. And we also have been working on a slightly better theming for dialogues, things that pop up over the UI to give you better contrast between the application below, but also a pleasing look to the interface elements that display to your user. And also text handling. This is being rebuilt basically from the ground up. I want to shout out to Chris, Benoit, and others in the GoText project, and from the team building the Geo toolkit. They have put so much work into this that we're hugely indebted to them for the work that they've done. So this brings a much more sophisticated layout and rendering engine for text. It means that complex glyphs are now going to be rendered correctly. So for non-Latin languages where two Unicode characters would come together, for example, to influence how something is displayed, that's going to operate correctly from our next release going forward. It brings in support for bidirectional text. Actually, as you could see on the slide on the right, that's an example. There's two different directions of the way the characters are composed there, and that's going to be rendered correctly going forward as well. Another benefit is that we just get crisper, more efficient font rendering. So it helps the theme look as good as it does, but it also is going to be much quicker and more efficient on memory usage. But mostly, this is enabling full internationalization further down the road. We've been amazed to see how well people are succeeding in languages that we haven't supported directly in the toolkit, but we're going to make sure that all of those people are just as loved as everyone else in the community from this release onwards. And lastly, the cloud sync and storage. This has been in development for a little while, but now is a core part of the toolkit, and so you can synchronize the data in your Fyne applications right out of the box. We're able to sync the user data and also documents that users might create inside your application. We're working to deliver various different cloud providers, and also, of course, the ability to bring your own provider into your application. There's a lot more about cloud data and synchronization later on this afternoon. So yeah, some of those features are already available. Most of them are coming in the next release, which is landing in mid-November. I can't wait to get this out and see what everybody makes with this new functionality. Thanks so much for your feedback on what we've done to date and the help testing to make sure that this is as great as it possibly can be. And so welcome to FyneConf 2022. Everybody who's joining us now on the day or watching these videos later on. We have for you 3 hours of great presentations that are going to be streamed through this live stream as we go. We're covering all sorts of topics around code, design, and best practices for the Fyne toolkit and building applications. And we're going to wrap up later on with a question and answer session with the Fyne team. And everybody is open to join us there. We shared the information earlier, and of course there'll be a link just as we wrap up later on. So please do join us if you think of any questions. But also, if you have any questions that you're just burning to get answered as we go through the day, please do ask them as they come to you. We're going to be monitoring the communities on Slack, Discord, Twitter, and the YouTube comments and questions section, and we'll endeavour to answer the questions at the end of each of the segments that are being presented. So pop your ideas there, or feel free to ask them face to face later on. We are very thankful indeed to our generous donors and community sponsors. There's too long a list to name, unfortunately, but we have them all on our website. Thank you for your ongoing support of the project. And also this year, thanks to Fyne Labs, who have sponsored the event. They have provided the speaker t-shirts, which a few of our speakers are sporting today, and they'll be sent out to everybody who has pre-recorded a contribution to the project. And I think that is everything from a welcome. So we will take a short break now before our next segment, which is about the interfaces behind custom widgets. Thanks so much for joining us today. If you have any questions, pop them into the chat right now. I'll try and answer a couple before the next segment. But I will see you again later on, and enjoy the afternoon.
Hello everyone and welcome to my talk, The Interfaces Behind Custom Widgets. I'll give you an overview of how you can use interfaces to tune the behavior of your widgets. About me then. My name is Jakob Alsen and I am a second year computer science student at Linköping University in Sweden. I do a lot with open source and I'm part of the Fyne team. I'm an amateur photographer and also a runner. You can get in touch through the Gopher Slack at Jackals, or you can find my GitHub profile at github.com/jackals. Well then, let's dive right in. So, if we want to show something on the screen, we can use a canvas object. These are the most basic graphical objects that are available within Fyne. They are simple and they are performant. We have 8 provided canvas primitives. We have the image, we have the rectangle, the line, the circle, the text, the raster, the linear gradient, and also a radial gradient. And the canvas object is an interface which provides a min size function which returns the minimum size the object can shrink to, a method to move it, a method to get the position, a method to resize it, method to get its size, and then methods also to hide and show it and to know if it's visible or not, as well as the refresh method to update its content on the screen. It's also worth noting here that containers are also canvas objects. So if you're interested in containers, how they work, and also how you can use layouts within the containers, I strongly recommend that you have a look at my talk from FyneConf 2021 for more information. But let's say that we want to display our own object on the screen. Then we want to use widgets. And widgets are basically a canvas object with a renderer attached. So the widget interface just has to implement the canvas object and then also have a create renderer method, which returns a widget renderer. And the widget renderer interface has a destroy method, a layout method, and a min size method, an object method that will return all the objects that are to be rendered, as well as a refresh method. And widgets give access to more functionality because we can use some interfaces that are available within Fyne for adding and controlling behavior. And Fyne will then internally check if the widget implements these interfaces and automatically call the methods if available. Some examples that we have of the widgets are, for example, buttons and the form widget that you see here, which has some entries that will take text input when you type on your keyboard, and so on. Here's another example of a card widget, which has some text in different sizes and a radio widget and an image. But how will we then implement our own widget? One of the easiest ways to do this is using a base widget. It's a helper that handles basic widget behaviors, basically. But you need to remember to call extend base widget that you see on line 22 there. What you basically do using a widget.base widget is that you embed it in a struct, and then the Go compiler will make sure that your my widget struct in this case implements everything that base widget implements. We can also use and then we of course need to create a renderer, but we can then use the widget.simple renderer if we want to very easily just create a single widget renderer from a single canvas object if we don't need more functionality from the renderer. The example that we have here just basically wraps a canvas object inside the widget, and then if the canvas object is a widget, then we use the create renderer from that widget instead. But then how do we implement an interface, as we've been talking about? And all we have to do is look at the interfaces that Fyne has available. We'll talk more about that later. And then implement the method or methods that are listed. So let's show double tappable in this case. If we want to implement Fyne.doubleTappable, we want the double tapped method, which takes a pointer to a point event, or a Fyne.point event. Then when we implement this, we just add the double tap method, and we'll just, for example, put a print that prints the position that it was double tapped at. And if we want to, which we most certainly want to make sure that our code is working correctly, we can add a check to make sure that the compiler will give us an error if the widget doesn't implement this interface. It's a bit of magic basically, where it will try to cast nil my widget to the interface. Now that we know how we can implement interfaces and then use them, we can get started with some of the basic ones. For example, if we want our widget to be able to receive events when tapped, we can import the fyne.io/fyne/v2 package. And there we have Fyne.tappable, which has a tapped method. And this tapped method will automatically be called when the widget is tapped. And then Fyne.doubleTappable, we've shown that before, but that just has a double tap method, which will get called when the widget has been tapped twice in succession. And lastly, in this case, we have secondary tappable, which is similar to others, but this tapped secondary is instead called when either the mouse has right-clicked on the widget, or if you have long pressed on a touchscreen, for example. And if we want to move our view, we can use the Fyne.scrollable interface, which implements a scrolled method that takes a pointer to a scroll event. This will get called, for example, when you use your scroll wheel. We also have the Fyne.draggable, which has two methods, a drag method, which takes a pointer to drag event. And this basically means that the widget will be notified when you press and then drag with your mouse. And then the drag in method will be called when the drag is over. And we have some focus related interfaces as well. First we have disableable, which has enable, disable and disabled methods. This basically allows a widget to say if it's enabled or disabled, and then the focus manager will use this to make sure that the disabled widgets do not gain focus. And speaking about focus, we have the focusable interface. And here we have four methods. The focus gained method, which will be called when the widget receives focus, and then focus lost, which will be called when the widget loses its focus. And then while the widget is being focused, we have the typed rune method, which will be which means that the widget will receive the character that has been typed on a keyboard. And then the typed key method, which is similar to rune, but it gives a key event with the actual key and not just the character. And then lastly, for the focus interfaces, we have the tabbable interface with an accept tab method. And this means that a widget can tell the focus manager if it will want the tab keys as part of when it is focused, or if those tab keys instead should be used for moving the focus within the application. And then lastly, for the interfaces within the regular Fyne package, we have the shortcuttable interface, which allows the widget to listen for shortcuts. So for example, it will be notified when you make a copy shortcut or paste and so on. And then we have validatable, which allows the widget to say if its input is valid or not. It also has a set on validation changed method, which allows parent widgets to hook into and be notified when this validation state changes. It's primarily used at the moment within the form widget, which will make sure that the submit button is disabled if all of the inputs are not valid. Now moving on to the desktop package. We can import the fyne.io/fyne/v2/driver/desktop package, and it provides a driver specific to desktop computers or devices, if you would like that. So we have the desktop.cursorable interface, which allows the widget to change the cursor when you move over the widget. So for example, you can make sure that you have this resize cursor when you're resizing something, or you can have the I-beam cursor when selecting text, that sort of thing. We also have desktop.hoverable, which allows the widget to more specifically see when a mouse is moved in and when the mouse is moved within the object, and then also when the mouse is moved out. And then keyable is like an extension of Fyne.focusable, but with added methods for key down and key up. Key down will be called when a key is pressed down, and key up will be called when the key is released. We also have the mouseable interface, which is similar to keyable but for the mouse. So you will receive the mouse down method will be called whenever a mouse button is pressed down, and the mouse up will be called when the mouse press is released. And then lastly, for all of our interfaces within Fyne, we have the fyne.io/fyne/v2/driver/mobile package. And this package provides a few interfaces that are more specific to the mobile side of Fyne. So for example, we have the mobile.keyboardable interface, which again extends Fyne.focusable, but with a keyboard method. And this is, I guess, a bit similar to the cursorable within the desktop package, but instead of specifying a cursor, you specify what type of keyboard you want the mobile device to display. So for example, if you want a single line keyboard where you don't want a return key that makes a new line, but you want to submit, this will allow you to do that. If you want a password keyboard to hide the password from third-party keyboards, and also numeric keyboards. And lastly, we have the touchable interface, which works a bit like the desktop interfaces we had there, with that but instead that you'll receive a touch down when the touch is pressed down, a touch up when the touch is released, and also a touch cancel if a touch has been cancelled. Now we should talk about how we can put all of this together and use it. So we'll want to implement dragging and scrolling in this interface, in this example I mean. And to do this, I'll use some 3D wireframes using linear algebra. You don't need to know any linear algebra to understand this, but I'll just use it because we can quite easily show lines in 3 dimensions. So we want the view to be rotated when we move our mouse. We can do this by implementing the Fyne.draggable interface that we talked about before. And if we want to zoom in and out, we can use the scrollable interface to receive scroll events. So let's implement our line drawer by extending the base widget or adding the base widget into our struct, for example. And then we start with the dragged Fyne.draggable interface. So the dragged method, we take our drag event and then we calculate some cosine and sinus into a matrix, a rotation matrix, to make sure that we move around all the points or lines accordingly, and then we call refresh on our widget to make sure that it is updated on the screen. And of course, as we showed before, the line drawer, the Fyne.draggable interface, I should say, implements 2 methods, or has to implement 2 methods, dragged and drag end. And while we don't need drag end in this example to do anything, we need to add it to make sure that our widget satisfies the interface. And then we have scrolled. We implement the Fyne.scrollable interface, take our scroll and move it to modify it so we get it inside the correct values that we want in our identity matrix that we then can scale our whole points with, all our points with. And then lastly, we refresh our widgets. And this is what we get. A set of lines in 3 dimensions that we can rotate around by using our mouse, and then also use our scroll wheel in this example to magnify, if you want, the object. And all the code for this is available at github.com/jackal/linedisp, and the linear algebra is implemented in using one of my packages called linalg. Thank you all for listening. The API documentation for the Fyne standard interfaces within Fyne can be found at pkg.go/dev/fyne.io/fyne/v2, and the desktop specific interfaces are all within the driver/desktop package, and the mobile specific interfaces within the driver/mobile package. Thank you.
and welcome back. Thanks for joining me in this segment about best practice when you're building Fyne applications. We're going to talk about how you can keep clear and maintainable code from the beginning of your project all of the way through so that your graphical application can stay clean and easy to work with through the life of it and not rot along the way, which sadly too many projects are accustomed to. Let's start right at the beginning with your project setup. Now, apologies to people who are joining us with a lot of Go experience or have built lots of applications in the past, but I thought it would be useful just to start from the very basics. And the very basic is make sure you have source control set up. I think that Git is pretty much ubiquitous in terms of setup for Go projects, and it would certainly be recommended. Not only do you want to initialize your source control or your Git repository, but you want really to figure out where it's going to be hosted, because that's going to help a lot a little bit down the road when you figure out which bits of it you want to share, who you want to give access to. So if you're setting it up on GitHub or GitLab, then this would be a good time to do it, because that's going to lead directly into your module name. If you can use a namespace that is globally unique, then a lot of things get easier when it comes to sharing later on. And if you have source control on a centralized system like GitHub, this is an opportunity to put it in your module name. And if you've issued many go get commands yourself, you'll know that this feeds into how things are discovered, installed in your Go path and module caches. So getting it right from the beginning makes things a lot easier. I would also recommend taking this opportunity to install some of the standard tooling that is available to keep your code in good shape. GoFmt or Go imports or newer versions are available. Definitely a good place to start, making sure that your code is in a standard format and doesn't make potential mistakes of white spacing or misleading indentation. And Go vet, although available in the standard Go tool, is a really helpful thing that you should run fairly regularly to make sure that you're not making other common mistakes in your code. If you don't know Go imports, you can go get it from this URL here. That's the one that I use mostly, and we've had a lot of good success keeping everything organized, following their rules. I would also recommend setting up a static checker. One is available at the URL there, highly recommended, and that is going to perform static analysis on your code. So it can look at your source code and figure out if there are harder to see problems with what you've written. It might be that you've accidentally included a security vulnerability, or you're using variables in a way that's not obvious from your code. It's going to be able to say, we think there's a possible mistake here. So adding to what GoVet can do and making a lot more checks to ensure good code going forward. This last one, perhaps not something that everybody agrees, but I think it's really helpful to have a complexity check against your code as well. So I would recommend GoGet for GoCyclo. Now that is going to check on your application code that no methods are getting hugely complicated, and so everything is essentially supposed to be more readable. It's making sure that your methods don't get too long, have too much indentation, and so you don't accidentally start doing too many things in one place. So that's your tooling setup, and the Go module file that you see illustrated there is probably a good place to start. You have your namespace, a reasonably up-to-date Go version number, and of course you'll have installed you'll have installed Fyne v2, which 2.2.3 was pretty recent when we recorded this presentation. You're set up and ready to go. But if you have an opportunity, you can automate some of these checks as well. So instead of having to remember to run the tools or asking other people who start work on your tools, you can set up these hooks and automations that will help. Git provides the ability to have all sorts of hooks on various different stages in the project lifecycle. I would recommend looking at pre-commit. This is a hook that's going to run each time you're about to send some code out to GitHub or to your collaborators. It is configured locally per clone, so this is not something that's going to be sent out to the repository and forced on everybody that you're working with. But nonetheless, I think it's a really good idea, and I end up copying my Git hook across all the repositories I have. I've included here a perhaps complicated looking hook, but I find it really helpful. You can see an example of this in the Fyne contributors documentation. Essentially, it is running through format, test, vet, lint, and cyclomatic complexity, one step at a time, and if the command matched to that label fails, then it stops and outputs an error message into your console. So this is going to run locally each time you're thinking about committing that code. Even better is to have it on the remote system as well, so that you don't have accidental configuration improvements on your system make a difference on whether something passes or not. So like I said, if you're on GitHub or GitLab, there's the opportunity to use hooks on the pull request cycle perhaps. And so you can run things like vet, format, and static check on their infrastructure, which means it's free of the biases of your local computer. And you can run the unit testing that you'll have set up as well. We'll talk more about that in a moment. And it's a good idea, if possible, to make sure that's running on different operating systems and possibly different versions of the Go compiler as well. I haven't included examples about how to do that here because it's going to vary based on platform and possibly over time much more than the local tooling will. And while you're setting that up, it's a great idea to report on code coverage as well. That is, how much of your source code is tested by one of your automated unit tests. There's a lot of tools out there as well that work in this area. We use Coveralls, which has got a good report and hooks into the GitHub flow that I use in most of my projects. So we have our project set up, we're using all of the best tools to make sure that our code is clean, and we are enforcing that through automation on our remote service as well. So we can see that everything is as healthy as it should be as we add code. But we haven't really added any code yet, so let's move on. And I thought it'd be really interesting to talk about packages. People coming to Go and also to Fyne are often feeling that they don't have the right package set up. Which directories should there be here? Are they putting everything in the right place? Well, the super secret thing here is actually don't add any packages too soon. If you don't know why you want a package or whether you need one, then you probably don't. So I wouldn't worry too much about it. The one thing that then leads you to is your main package should be at the project root. Simple, you have one package, it's the only directory. And so you would then have the Go module file that we showed before and your first Go file, main.go, in the current directory, which is the root of your project. This means it's really easy for people to discover and build your application. They don't need to know or to figure out which subdirectory it's in, where in the tree they might find relevant information. It is possible, and I understand that people don't necessarily like this because other files might appear at your project root. README files, configuration for other things. But if you're keeping it just to these three files, which we will do, there's not too much worry about that. And it's your entry point, it's not the bulk of your application logic. The next thing that we might want to add is an internal package. That's going to allow you to keep code separated so that you've got a good separation of concerns between your main code and other items like the calculation logic that you might have in your app, and grouped by area of application such as logic. And anything in internal won't be discoverable or accessible by external systems, so your only entry point is the main package and the main file that we created already. Now that we've started to gather code in our project, we want to make sure that the graphical user interface files are separate from the rest of the application. This might seem a little bit difficult to do, but we'll cover some strategies there. Primarily though, by keeping these separate, you can focus on an API for your application that is clean and easy to understand, and the user interface, which is a simplistic way of presenting that to the end user. It's another way to ensure separation of concerns and a cleaner API by having these items separated. If you put it all together, you're able to break certain assumptions, files get bigger, and actually untangling it later is much harder. We recommend also, as illustrated there, one file for each area of your application. So the definition of area is going to vary based on different systems, but perhaps it's related to a screen. So you might have a search screen and a welcome or landing screen. You may also choose to put certain complicated dialogues into a separate file. It's up to you. Just make something here that is understandable by people who are joining into your project. At this stage, we have some files, pretty clear of their usage. I wanted to talk just a little bit about the structure of your code itself. I've entitled this Small Files, Small Functions, Clean Code, which might resonate with anybody who has seen the work. This might resonate with anybody who's seen the work of Uncle Bob Martin and his Clean Coders book, video series, and website. He has a lot of great things to say about how to organize your code, how to keep things simple and clean. And so we showed before, multiple files with clear names is going to make it easier for people to get into your project and understand how to start contributing early on. And that's not just useful for open source projects, but it could be really great for anybody onboarding into your team, having come from somewhere else, or into your company. And any helpers you can give them along the way is really important. If possible, try to keep to one main type for each of these files. So an area of the application might have its logic in the search type, which can be interacted from other areas. It's not necessary, but as you can imagine, that means that you can define the functionality related to search at a level that could be discovered and presented in your development environment rather than trolled through in a massive file for somebody trying to find the right thing. And at that time, whilst keeping things small and simple, the clean coders tell us that functions should be really simple. They should have one main purpose. This is sometimes difficult to really understand how to, in a large application, keep it simple. But if you keep to that mantra, then the function names will be quite helpful. Each function is only going to do one thing, so its name is going to tell you what it does, and you don't now need to look 3 levels deep in complex logic to understand what's going on. And in having one main purpose, remember also a function would need to be a getter or a setter or a logic of some sort. So you can see from the signature whether it is receiving information and processing it, returning information, or setting it through some sensible name. So a lot of hints can be conveyed through simple, short methods with well-picked names. And although I said it before, this applies also to user interfaces. A big complex screen might feel like it's one piece of functionality, but it's made up of so many different pieces. It's better to split that up into small sections, and the function that perhaps builds the screen that you're talking about is really calling into lots of different smaller functions that come together to create the user interface and the functionality that you want. So thanks very much, Uncle Bob, there for your recommendations, and do check out the website or his book if you haven't done before. He would also tell you, of course, unit testing is tremendously important. I completely agree. I don't want to step through how to write lots of different unit tests, but suffice to say that the design that Go promotes for good testability follows through into the design of Fyne. A graphical widget or component can be tested just as easily as any other part of your application, as we illustrate in this example here. We're wanting to write a test that tests the selected text of a widget. So we create a test called test text selected. And in there, we create a new entry widget. We use the test utility package that's been imported above from fyne.io/fyne/v2/test to simulate typing the letters hello into that entry. At that point, we can assert that the text inside the entry equals the string hello. That's pretty straightforward, but we can do something a little bit more complex. We can double tap in that space, again using the test utility. And in that case, what we would expect is that the selection has covered the text that the mouse was over at the time. And so we then check that the selected text is equal to hello, which it is, and also that the cursor has progressed to the end of the section that we were selecting. We do that by checking that it is 5. That's pretty straightforward. Of course, larger areas of functionality require larger unit tests, but that shows what is possible. And we've illustrated in the file listing there that there is a test file to match each of our code files. So the search screen has some tests and the welcome screen has some tests. And of course, naturally we drop them into our calculation code as well. But we can do more, and you might need to do more when you're testing graphical elements. So we've called this render testing. It's about validating that a component or section of your screen is rendering as expected. In the illustration here, I've made new test files that separate render testing from a regular unit test, so it's clear which that you're going to be finding in the file. So for each of our screens, we have a new file called render test. And these tests are able to execute normal unit tests, but also we can use that same test utility package to compare what our widgets are doing with a PNG graphic or an XML description golden file so that we know that the right thing has happened. To compare visually, we have assert image matches. That's going to use a PNG file to make sure that what has appeared on screen matches what you're expecting. And assert renders to markup is going to assert that the widget tree leading to the result is the same as you were expecting. So you can compare both what the user is seeing and the way that it's functioning, the state of the objects under the hood. Now, I say it's verifying what's on screen, but actually all of this unit testing happens in memory. We're using what's called a headless driver, and so you're not going to see this appear on your screen. You're not going to lose control of your mouse as it taps around inside the interface. So these are far less inconvenient, but also execute a lot faster than unit testing that you might have used in a web page or a Selenium driver, for example. In our illustration of files there, we have a new folder called test data. This is where we store the comparison files. We have a search for foo image, which I would imagine has the search widget set up. The word foo has been typed in and possibly enter has been hit or the search button activated. And also we're capturing the welcome start state in an XML file. But how did we create these? Do we really want to be manually creating all of these golden files? Well, no, that's not necessarily, thankfully. There will be a new folder created the first time you run these tests called test data failed. It's inside the test data folder, and it will contain the image or XML that was encountered that didn't match the expectation. So this is going to help you understand how something failed once your tests are running more frequently. But when they run for the first time, it's going to provide what did happen, and you can then move that into the test data folder if it's the right thing. So be sure to check the content. Visually, the PNG should be clear whether it's doing the right thing, and in the XML regard, a quick read through should clue you as to whether it is what you expected. And from there, in the test data folder, the next run will pass, and changes that were undesirable will again appear in the failed folder later on. So that's the different ways that we can test our code, but you should also use the Fyne app metadata file. It was mentioned earlier on, and here is the same illustration again. The reason this is important is because you could store metadata about your application in the repository, which leads to clearer conveying of that information, but also reproducible builds. You're not passing these parameters to build commands, forgetting one item, did I use the right icon or the right version number? So it all happens automatically, which also means you don't need to use build scripts. And this is a big plus. Go functions really well out of the box without anything like make files or scripts of any kind. And by integrating a metadata file, you can take your Fyne application from the first line of code through to delivering to your users without needing to script or add complicated parameters to anything. And it also leads to a smoother release process. You will perform a release, any added information required will be asked, version numbers will be incremented, and your release will complete automatically. Much smoother than lots of command line parameters. Lastly, I wanted to touch on custom widgets. This is an area that perhaps raises many more questions. What's the right way to do things? How exactly should I be laying things out? So here I'm illustrating a creation of two new custom widgets, one called map and one called picker. They have their own test files and their render test files. You'll notice that we've created a new internal package called widgets. Now this is so that our application can use these reusable components anywhere in its code, but they're not readily available to outside scrutiny or usage. You could share this code by exporting its constructor and moving the widget package out of the internal area, or of course you could contribute it to a shared repository like FyneX, where people can around the world get use of your code. But for now we'll leave it in the internal place. Much like regular types in a file, we recommend only one custom widget per file. It makes it easier to discover and easier to debug when you're stepping around and seeing what's happening with more complicated behaviors. And you can see we've added our unit tests and we're validating the look and feel. And now we come to the design of an API for a widget. It's very important to expose as little as possible to publicize only behavior-based information for your widget, so that your users are not going to be confused by a huge number of different functions that might be available, thinking, what name would I give to an activity, and how would somebody interact with my widget to do that? And similarly, we store state, but we only expose or publicize the state that we want somebody to be able to interact with. So we might have some public state, we might have some internal private state, and here it's saying to store it only in your widget, because you don't really want it external to the widget, because then if you have two widgets, they're going to conflict. We'll talk about a widget renderer in a moment, and you don't want to put too much state into the renderer either, because the widget is the behavior, it's where the core state it should be. And touching on renderers, don't store a reference to your renderer. It's the widget's responsibility to create a new renderer so that it can be displayed. But this renderer can go away at runtime. It might be cleaned up through some memory requirements, or it might not be used for other, might be not needed anymore for other reason. And if you store a reference to it, you may get crashes through nil pointers, or you may just find that you're manipulating something that's not visible anymore, and you lead to a very complicated debug process, which ultimately was because it was an ill-advised thing to be doing. So let's look at a behavior-based API for a custom widget. First of all, we extend base widget, and we remember to call extend base widget in our constructor, and that's what allows the internal code in base widget to know the type of widget that it's behaving on behalf of. Export any fields that you want to be available through some sort of configuration, and create really helpful methods with good names that don't describe how a user might do something, but describe what it is that they're trying to achieve. And so here we have an illustration. Our new map widget is called map, and it's exposed. There's a capital M there so people can use it. We're extending base widget, and we have integrated here a watermark feature, so they will be able to pass what information should appear over their map. And internally, we're going to be tracking the zoom level and the XY coordinate. That's not something that we want people to be able to write to or necessarily access directly, because that is internal to the state of our widget. It may relate to rendering, but we know that it matters to remember this information irrespective of whether it's visible or not, because that is the state that the user has put the widget into. We create a little constructor there, and we remember to call extend base widget. And lastly, we've created a new function called zoom in. I don't think that people would really expect a prize for guessing what that does. How it does it is hidden behind that comment zoom code, but we're performing whatever adjustments are necessary. And then we're calling refresh on our widget. And that's telling the base widget and the overall Fyne toolkit something has changed, we need to draw to screen again, but we don't need to know the details, so we just call that one function. Now that takes us to the renderer of a widget. We have, as I mentioned before, stored the main state in the widget, so we don't need to do that here, but we can store disposable information, caching information, something that helps the renderer indicate that it can be optimized based on some state that isn't the user state, but is relevant to how it's drawn on screen. We need to make sure in a renderer's refresh that we take any state that can be modified from the widget and apply it to our render state. And during layout, we need to be sure to adapt to the size that has been made available. A widget will always be bigger, or at least the same size, as its minimum size, which is declared in your code. You need to think what truly is a minimum size. We will always be bigger than that. Don't put something too big. Don't be encouraged to put a preferred size as your minimum, because then it's not going to function very well on small screens when you could truly have actually rendered, but you'd prefer larger. It's the job of a layout and a container to make your widget bigger as the space becomes available. And remember, because a renderer can be destroyed at any time, it's important that any heavy resources that you might have held on to get freed in the destroy method. We don't know, and there aren't guarantees about how frequently a widget will be created and a widget renderer will be created or destroyed. It's not going to happen very often, but it can happen, especially on more memory constrained devices. And so here's our map renderer. It's not a particularly exciting one. We just have a raster cache essentially, but we start by implementing the create renderer function on our map, which creates a new instance of this map renderer. We pass our widget, our map, into it, so it has a reference to our state, and we set up this raster for our cache. We also have a type assertion there to make sure that our widget renderer is truly a full widget renderer. This means that we get compile errors rather than runtime errors if we accidentally miss a method, typo, or if for some reason the interface definition changes. We then have our struct, which represents that data that we passed in. We're not doing anything in destroy because there's not a huge amount to do. That raster cache will be cleared up when our renderer goes away. Our layout is simply to set this cached raster to be the full size of our widget, and we have set the min size to 50/50. It's a little arbitrary in this case. If your widget was more based on textual content, you might want to measure each individual item and add them together. Now, the way that the renderer is conveying to the toolkit how to render is that we pass a list of objects back, and in our case, it's just this cache. And in refresh, I've omitted some code, which would of course draw the pixels of the map and overlay the watermark from our map widget. Now that's a lot of boilerplate, I suppose, to do something quite straightforward. And so we have introduced a new type called simple renderer in the widget package, which is really going to boost productivity for building trivial widgets, avoids creating a custom renderer completely, and where we returned a list of objects from our object method on the custom renderer. We just pass these objects into new simple renderer instead. We need to make sure that we apply any changes to the objects that we've passed through in our widgets refresh method, which will be called before the decision is made as to whether anything needs to be changed in the renderer. And because this is a default setup, the objects passed in will fill the space available because we're not controlling the layout anymore. So it's like the max container. Now, if we wanted to actually have a more complex layout with static items that were represented in a simple widget renderer, we could. We would then pass a container as the object that should be rendered and lay out the items inside that container like you would in any other setup. But isn't that a lot easier to understand than the boilerplate that was created? This is the entire replacement. The custom type wasn't needed at all. In the create renderer, we create a new cache if we need one, and when we pass back a new renderer that's going to lay out this cache. And you might notice it is slightly more efficient if the renderer is coming and going, because we can reuse the same cache. but it does mean that the cache may be created sooner than in other cases. But roughly speaking, it is about the same memory utilization. And so there we have custom widgets as well. But before I go, I wanted to just leave you with a couple of thoughts. Export only what should be public, or export only what you want to support. You've put your code out there potentially as an open source project on a publicly available repository. If you have a public API, somebody might use it, and that would be great until you realize that then they don't want you to break it, because otherwise you'll get an open support ticket against a project that you thought was just a little bit of fun, or a widget that was used internally. You should document all of your APIs. This is not just for best practice because your boss said it would be a good idea, but it means that your IDE is going to be able to tell you about the function call that you're making. And if you need to go back to it, not only are your team potentially going to be happy that you've documented your code, but your future self also might be happy about it. Naming is tremendously important. Don't just put something there temporarily in the knowledge that you'll come back to it later, because who knows about later. Make sure that your API is clear. The smaller your function, the easier it is to write a good function definition or naming. It's always going to be simpler when the scope is small. Everything is clearer and you're going to have a really good idea about how something should function. Always better, I think, to have good naming than the documentation, because that way it's going to be a lot harder for it accidentally to do the wrong thing. It's right there in your code. But back to the beginning, start simple. Put together the minimum, get it working, and see how it goes from there, building on it slowly. Ask the community for help. As Gofi in this image here would tell you, the Go community is really welcoming and very helpful. Don't feel like you can't ask a question if you're just looking for a little bit of advice or guidance along the way. I hope that's been really helpful for folk to understand what we think are best practices when it comes to building Fyne applications on top of the Go programming language. I think we're out of time for questions on this topic, unfortunately, but do join us in the Q&A later and we will progress with our next topic in a moment. Hi everyone, I hope you're enjoying FyneConf this year and have learned a lot from the earlier presentations. Our next segment is about Cloud Sync and storing your users' data and documents in the cloud from a standard Fyne application. We're going to try and help you to see how your data can be as ubiquitous as the applications with a platform agnostic approach. But I suppose for anybody who might wish to question why the cloud, I thought it would be good to have a couple of thoughts about why this is something important and why now. Well, I mean, we're now in a place where people are working everywhere. Users who are using your applications, building their data, really should and expect to have access to this data whenever, wherever. Your Fyne application, like any other, is going to run on absolutely any device. But that doesn't mean that the data follows, because it's currently stored locally to that device. So if you are working remotely, if you're traveling backwards and forwards already on the train, or if you are spending a lot of time back in the office, can you remember which device you were using for the file that you were working on? Where is your stuff? Is it on your tablet, your laptop? Is it sketched onto your phone whilst you were in the queue waiting for coffee? Well, as a lot of applications have been starting to realize, it is possible to make the data readily available. And in fact, this kind of storage is really expected on a mobile ecosystem. We've seen tremendous advances through smartphones and tablets and synchronizing in a particularly platform-specific approach. And so we want to make it possible for your application data to follow not just as well as the platform-specific approach, but on all devices and all platforms. And the trick is, how do we harness that into a Fyne application with as little hassle as possible? Well, this is the cloud opportunity, and we are going to make the most of it. We're going to be persisting the user data to this remote service. In Fyne terms, that's the preferences and the documents which are stored through the storage API. These items are going to be taken and pushed onto the cloud services, so you don't need to do anything specific about cloud to make this happen. There are different providers available, including Dropbox, for piggybacking on top of a platform that people might already be paying for. And Fyne Labs and others are also working on their own implementations that will provide Fyne first-class citizen for storage to the cloud from Fyne applications. And of course, it's important that anybody building an application can sit that on top of their own cloud system. And so it's entirely possible to build your own provider for cloud storage and put that into your Fyne application in the same way. And hopefully, through the next few minutes, we can demonstrate that storage to the cloud using Fyne is as easy as it is to build your first Fyne user interface. So let's jump into a little bit of code here. How would you integrate a cloud provider, assuming that you found the one that you were looking for, into your application? Well, here we have our application main. It probably looks quite familiar. We're setting up an app, we're creating a new window, and we're running it. The key difference here is we've called set cloud provider. It's one line of code that has changed this from a local data stored application to a cloud stored data application. We're using the provider from my cloud, which for the record is not one of the cloud providers but is illustrative here. And so the user preferences and storage is now going to be completely transparently uploaded to the cloud, as well as being available on the device. No other code is required for your Fyne app. It's that easy. Of course, we probably want to look a little bit into how can you make a cloud provider, because it's quite possible that the ones that are out there, at least at this stage, aren't the ones that you're looking to integrate into your system. So let's just have a little bit of a look at the interfaces and the workings of how to do that. First of all, we need to implement a new interface called Cloud Provider. That is going to allow our code to describe what the provider represents and its capabilities. We have a setup method defined in there, which is where you can perform any login or authentication. In the case of Dropbox, you probably don't need to do anything because it's set up externally. But if you're integrating with a new service that is not known to your device, you're probably going to need to run OAuth or some other handshake that is going to identify you to the remote system. So that's what the setup is there for. Obviously, we want to export that type or provide a constructor so that, like in the illustration of the previous diagram, somebody can then pass that into set cloud provider so that their application is ready to run with your implementation. And then we add the actual functionality for delivering cloud elements. There's two main areas at this time. Cloud provider storage is an interface that defines how you can store documents, that is, larger items from the storage system. And we have cloud provider preferences, which is used to synchronize user preferences. Now that's just a bit of a quick overview. There will be more details to follow on how some of this is implemented. But for those who prefer a little bit more code and a little bit less description, this is the cloud provider interface. You see the first three methods are just describing this provider, and I'll come back later as to why that is quite important. And then we have the setup that I described and cleanup, which is essentially the other end of that. An application could have a cloud provider change in its lifetime, so it's important that we release any resources that were set up during the setup function. The storage provider is simply defined as a single method cloud storage, which passes in an app for context and returns a storage type. Now, if anybody's worked with the document and storage APIs in the last release or two of Fyne, will probably recognize that as a way to get your documents, to list the documents that you have available or to create new ones. And actually, this is exactly what it is. But the result is going to be used and injected into your application. So where local storage was used before, cloud storage is used now. And it's up to the implementation of the provider as to whether it stores locally first and synchronizes later, or if you wish to implement, for some reason, a blocking algorithm which will reach out to a remote system and wait until the data is available. And then essentially the same is provided by the preferences version. We have a cloud preferences function, taking an app for context, and it returns a preferences implementation, where the data that is being used is not documents, but is essentially a key value store. And now that leads into a little demo. Derek is going to come on stage and talk to you about how he implemented a cloud provider for preferences store to remote system.
Hi, I'm Derek Reed, and I'm here to show you how we implemented an offline first synchronized store at Fyne Labs. I've been with Fyne Labs for about 5 months, and it's also how long I've been writing Go. So, what do we actually want from a cloud provider? Well, we decided we wanted it to sync data between all the devices efficiently. We wanted it to be great offline, so if you enter some patchy network area, your app still works nicely. We wanted it to fit into the Go ecosystem, so we chose BoltDB, which is a key value store written purely in Go. We wanted to be conflict-free, with CRDTs and a last write win algorithm to ensure data convergence across all our devices. So, how do you go about doing something like that? First of all, we created a struct called lal preferences, and lal is our code word. It's Star Trek stuff. I'm not sure. Anyway, so in our preferences struct, we have a lock, some change listeners, and a wait group, which helps us to sync our data. And then we also have our DB of type lalDB, and that's just our wrap of the BoltDB, of BoltDB's interface. So the middle line here is to ensure conformity with Fyne preferences, so to make sure that we've implemented all the methods from the preferences. And we have our constructor here at the bottom, cloud preferences, which creates a new instance for us. So what are we conforming to? The preferences interface here has many methods with bool, float, int, string, setters and getters. So I'm going to show you how we implemented those in our solution. So here are some of our setters. We have bool, float and int, and they all take in a key of type string and the bool, the float or the integer. We use the same setter method to write to the database, and that takes in a generic interface which we have called value here. So in our set method on the allow preferences struct, we check if there's a database because we need the database, and then we use boltdb's update function, which gives us read and write access. So that gives us a transaction which we call tx here. We grab the preferences bucket, encode the value, and we use boltdb's put method to push that to the database. If all goes well, then we call fire change, which is a very exciting function, exciting sounding function. What this does is essentially it makes all the fields in the preferences re-get, so it ensures that the change was successful and the app is synced with the database. So if we have a quick look at the getters, so I'll show you the string one here. String with fallback is the method which calls or get on the database, but has a helper function there called string. But p.get is what we're looking for here. So let's have a look at get on our allow preferences struct. Once again, it takes in a string, which we'll call key, and our target interface, which we will write our result to. We can use Bolt Database's view function here, because that's just read. We don't need read and write access for this, which once again makes a transaction, grabs the preferences bucket, and it gets the key. If successful, it encodes to our target interface, which we can then use for whatever we like. Looking at the remove, very, very similar. We use the update function again for read and write access, grab the bucket, delete, and then at this time we call fire change again to resync the app. That's all very well and good. We now have our device and we have the database and they're happy. But what happens if another device over there, let's say I'm on my laptop and Andrew is on his phone and he updates something, my laptop needs to know what's going on. So we use a listener and a callback so that if Andrew updates the database, my laptop gets a message to then call fire change and my laptop will resync with Bolt Database. Excellent. So that's how we implemented our offline first synchronized store at Fyne Labs. Thank you very much, and I'll pass back to Andrew. Cheers.
Thanks so much, Derek. That was really helpful to see how that all comes together. I wanted to wrap up this segment with one other item about how cloud can add to your application. So as well as creating a provider and setting it into your application, whether you built it or you found one that somebody else made, it might be desirable to allow users to choose which cloud provider they want to use. Instead of hard coding the one that you think makes sense for your application, it could be useful to offer users the choice of how they synchronize their data. And so we are working on bringing that in for this current release as well. We're going to store this information globally where possible so that users' choice will be available everywhere, and their data from lots of different Fyne applications then is present in the same remote system and synchronized at the same time. So things like working maybe with your Dropbox provider or a complete desktop solution with one cloud provider is able to provide the same sort of seamless experience that platform-specific ecosystems have been adding for their applications. For this example, we're going to import a new repository called fyne.io/cloud and then call cloud.enable. Seriously, it is just that straightforward. Where previously we said app.setCloudProvider, this time we are using the cloud package to cloud enable our application. That's all the lines of code that you would need to cloud enable it. But we do still need an entry point for the user to be able to choose their provider and for potentially configuration to be done with that provider. So there's another line of code that we would certainly recommend adding, which is show settings. In the same package, we're passing the application for context and the window that it should appear in, because this is going to pop up a dialog. So in this example here, we have created a new main menu, the file menu, and added a sync item. And in there, we are saying show the cloud settings when somebody taps on that button. Again, not hugely complicated. And this is going to bring up the configuration screen using the current theme of the application, which allows the user to pick and configure their cloud provider. The providers available are currently set by the cloud repository, but we're working on ways to increase that and potentially filter it for your convenience. So do be sure to get in touch and tell us how this would work best for you, so that we can make sure that this is a good experience as soon as it's available for the release that we're shaping up at the moment. And of course there you can change provider, which is one of the reasons it's a really good idea to have your application tidy itself up when the cloud provider changes. And so there we have it. We have cloud synchronization for Fyne apps. The user data is going to be available absolutely anywhere, wherever they are. I think we showed it is really simple to set up and use. And it is using the same preferences and storage APIs that you have used in your application already. Of course, lastly there we showed how you can allow the user to pick a provider, or you can set the one that you think matches your application use case best. And overall, we have synchronized data and happy users. Hopefully this is going to work just as well for your applications as it has for the ones that we've built so far. But like I said, do feedback in the next couple of weeks as to how you find this gets along, and we will be able to add more to it as the release prepares, or of course new functionality in that cloud repository as it gets utilized across different applications. Thanks so much for joining us in this segment, and we will see you back at the next one shortly.
Hello everyone, I hope you're having a good day watching Fyne Conference 2022. I am going to be talking today about cross-compiling in the cloud with Kubernetes and how that is going to help you build for all Fyne on every cross platform that Fyne support. So the plan I'm going to be following today will be a short introduction of who am I. Then I will be covering a little bit about cross-compilation and FyneCross, which is a tool that enables that with Fyne. A little bit of what are the difficulty of working with all of these different platforms, even with that infrastructure, and how using a Kubernetes cluster can help you for solving some of these problems. And I will also cover why FyneLabs did develop and work on FyneCross to actually develop its own service that make it even easier. And I will come back to FyneCross and talk about the futures and where we are putting effort for improving it. So quickly, who am I? I'm Cedric Bai. You can contact me at cedric@fynelabs.com. Don't hesitate if you have any question later on to reach out. I am the current CTO at FyneLabs. We've been trying to create products that enable development of Fyne application more easily and more productive for the entire ecosystem. I have been a software developer for a long time now, doing C and C++ for most of my career, and I have been doing Go only lately. So the problem we're going to be covering in this video today is about the fact that each developer has mostly one computer to develop on, but all of these users are running on so many different OS and architecture. If you think about it, you have people running Android, BSD, macOS, Linux, Windows, and they have like x86 or ARM or even ARM64. So all of these variations give a really big matrix of platform you need to support. And for all of this platform, the solution, if you have only one computer, is to set up what is called a cross-compiler. And so Go does provide already cross-compilation for all of these OSs and platform OS and architecture together. But as we depend on some C library, or in the case of Fyne, we depend on GLFW, we actually need to have a C cross-compiler. And that doesn't actually mean that we need to have one compiler for each couple of OS and architecture. And that does really increase the complexity of setup and maintenance of all of these components across the board. So for that, it would be great if we had containers that were providing the tools already necessary and just for each platform, maintained for us and working just out of the box. And even better if instead of running manual things inside a container, if we actually had a tool that was piloting this container to do the build for us so that we don't even have to care about all of this setup. And that's exactly what FyneCross is. FyneCross is a really cool tool. It was created by Luca. Thanks a lot for his work. It's basically set up a container for each OS and CPU. They are maintained by FyneCross, and they contain the latest goals, latest Fyne, and you just need Docker or Podman with a Go runtime on your computer to be able to run them, and that's it. It will just work. And so a little bit of an example here. As you can see, we're trying to build for Darwin. We just go into the directory of the application we're trying to build. Well, when you are doing a public repository, thanks to the GitHub free tier. But as you might be building private repository, the resource that you're consuming are pretty high for supporting all of this platform, and you start to have to make decision there on what to support. And that's not something that is absolutely necessary, because you could actually offload most of this computation into your own infrastructure, making your cost much more predictable and into a nicer financial way for you. And that's why, like, most companies can actually set up a Kubernetes cluster and they can use it to offload your cross-compilation to it. It also will enable your users, your developers, to actually run their own build into the cluster so that you can be more productive even for a developer. It does enable to build much more in parallels, and you can size your cluster accordingly. So it's a way to improve your cost efficiency there, and especially when you're building application that you want to reach a lot of customer and a lot of different platform at the lowest possible cost. And so that's why we did at FyneLab work on the Kubernetes support for FyneCross. It's still in PR. There is still a little bit of discussion on how to integrate the Kubernetes part, especially the module that it depends on, which are have a lot of dependency, quite complex for just accessing the Kubernetes API. So there is quite a few ways we are still discussing, but it might come shortly. The code that it's based on has refactored already all of the code base of FyneCross to make it easier to add your own engine. So I will cover at the end how you can actually implement another engine. I am not too sure of how useful that will be, because after Docker, Podman, and Kubernetes, I'm not too sure of what will be the next one to implement. But who knows? It's easier, so we'll show it. So the Kubernetes FyneCross code will take care of creating pod into your cluster, control the build inside the pod, and retrieve the result of that build and destroy the pod. We use a temporary S3 storage to be able to push content to the Kubernetes cluster and download it into the cluster, because there is not really any other protocol to go by here. There is a lot of open source implementation and alternate services, so you don't really depend on Amazon for having a S3 storage. And from there, you can actually run the same FyneCross, but with the Kubernetes engine from your GitHub action or a drone deploy, which make your life quite easier, and you can actually leverage that simplification. Also, from your desktop developer station, you can actually just type FyneCross, like in this example, FyneCross Linux -engine Kubernetes, and it will actually upload the project that you are building locally into S3. Then it will download it into the cluster pod, and it will also do automatically the caching of the build for you. It then does exactly the same thing that the FyneCross locally was doing, do the building of the binary, package the app, or generate the tar.exe, and will actually download it back on your local machine. And that's basically as easy as it gets. We do have a lot of command line argument that you can actually use to specify your S3 storage, your Kubernetes namespace, and things like that. It's something we could actually put maybe into environment variable or into a file, config file, At the moment, we haven't really done anything like that because we don't really have a use case, but if you have any suggestion, just reach out. That would be interesting to add. But that is still quite a lot of work to set that up, and actually we can make it better. And that's the reason why FyneLab is using FyneCross. We have been trying to build a build system to deliver apps across all the platforms that and the OS you want to support, and that's it. Here you go. So we support private and public repository, and as you can see, you have webhook, and so that every time you tag a build, it will be triggering the system, and you get to have nothing to do there. And the deploy key is used for private repository, so that we can access things there. And once it's done, you get all your binary that you can now test on all the devices, and you can exchange that and once you publish with your users to make sure that everything is of quality. And we are working there to go towards the idea that we should be able to deliver these apps all the way to the user. And so currently we are working on adding self-update support. We have already open sourced earlier this year self-update software, and we are using this solution to build our own infrastructure there. And so it will take care for you of when you push the publish button to make things happen into a CDN that your application can pull instantly and will be able to get their update from. We'll be working later on adding application store delivery or hosted portal, depending on what our customer kind of demand and prioritize. And the idea being that if people are more interested to reach to large customer base, application store is the way to go. But if it's more for people inside a company, hosted portal might be what they are looking for. So this is more of a product that will come later on. We'll see where we head there. But let's go back to FyneCross. And so we did a lot of work on the refactoring of the engine interface. And so as you can see now we have the container engine, which is in charge of creating the container image for a specific architecture and OS. We can also specify the container image we want to use for that couple. And the idea is that if you do have some C or binary thing that are not in Go but in other language, you can actually package them into your own container and be able to still use FyneCross to orchestrate things on top. So this is a way if you do have dependencies that are not in Go. And once you have created a container image, there is a few steps that will be taken care of by FyneCross. FyneCross will call you to prepare that container to be receiving order. I will cover just after what does that mean. And then FyneCross will run command in it that it wants to be able to do. So it expects find, go, and a few commands inside the container, so that it does actually it can build things inside the container. And when it's done, it will call finalize, which is expecting to be extracting that resulting package out of the container to transfer it locally and destroy the container after that. And so the preparation of the container image is when we actually are indicating to the engine which mount point locally we want to expose into the container, which environment variable we want, things like that. So in the case of Kubernetes, the mount point cannot be exposed directly from locally to the cluster. So we are actually uploading them to S3 storage and then downloading them back into the container. So that's what we are setting that up there. We need to have still storage into the container to receive this data, because the container in Kubernetes is read-only. So we have to set up a few mount points that have like a certain storage capability. And the second point is that environment variable in the case of Kubernetes are set once when you set the pod, and you cannot really easily override them otherwise. So the easiest thing to do there was to just set all the environment variable when we set up the container, and that's why we do that in this snippet. And with that, we're getting toward the end of a talk, and I want to talk a little bit about FyneCross future. So obviously, FyneCross is a community effort. It has been led by Luca to get where it is today, and it has really a lot of good ideas to move forward. One of the problem we have today is that we cannot provide a Darwin image because of Apple license on their tool, and so your user, all the users of FyneCross are forced to manually download and compile themselves the Darwin image so they can actually use it. This is not ideal, and there seems to be some interesting solution around Zig as an alternative C cross-compiler that seems also to be able, like Go, to compile for a much larger number of targets. So we might be able also to reduce the amount of container we have, which will reduce the burden on the developer on the storage of what he needs there. So that would be a really nice improvement. But what will be really nice is FyneCross is really useful to everyone, and it's really the way forward, I think, for setting up your environment, for compiling for any other platform than the one you're on. And that makes kind of a logical sense that we actually include that as part of Fyne and make that really something that Fyne does right away. So one of the plan this roadmap is to actually make it possible for Fyne to pick up FyneCross capability. So for that purpose, we will refactor a little bit more of the code into FyneCross so that the command line argument module match Fyne, and then we should be able to move FyneCross code into Fyne command line and be able to have a new FyneCross command line. And at that point, it would be really nice if we can automatically detect and magically decide when the OS we're running on doesn't have a cross-compiler setup or is missing something, and we should be able to say, oh, well, let's actually switch to FyneCross, download this image, and off we go. We are now able to support that platform without having the user having to install and maintain all of this for us, making basically Fyne as a tool able to support all the platform that Fyne the toolkit is actually able to support. And I think that's where we really will be aiming for, is to this great tool should be part of the core of Fyne, as this really enables a lot. And so that's how I will be concluding my talk for today. Don't hesitate to reach out on Slack or Discord if you're not able to attend later on the Q&A. I will be there to also answer your question. So on Slack I'm Cedric, on Discord I'm Bluebugs. And you can also reach out via email. And yeah, do not hesitate.
Hi everyone, and great to speak to you again. I hope that you have enjoyed everything that has been presented so far. I think I've learned something, hopefully everybody else has as well. Before we wrap up today and move on to the Q&A with the team and the community, I wanted to talk a little bit about the road ahead and where the project goes from here. So we actually talked quite a bit earlier about the things that are being developed for the v2.3.0 release that is going to be out there in a couple of weeks after the new community members come in through the Hacktoberfest program, and we start with the release in November. But there is a lot more that we're working on going forward. So let's have a look at some of the big items. So we're going to continue roughly with the release that we have, We're going to continue roughly with the release rhythm that we have been using for the last couple of years. We're going to be looking at large feature releases every 4 to 6 months, and then each month in between, if there's important bug fixes to get out there, we'll be doing a release roughly each month, which seems to have been working quite well. Of course, you don't have to wait for the next release to use some of the functionality. If there's a major bug fix that you want to be using, you can use that version number like Go will allow you to. In the module, just specify the SHA hash. And if you want to work with the latest thing, you can always go get Fyne at the develop version number, which is an alias for the latest thing that we're working on. Anyhow, what we are going to be doing as soon as the next release is out is to start the planning process for the series of releases starting 2.4. Actually, there's some work underway already, and we're pretty excited that this is going to include a rich text entry widget so that you can have fully interactive rich text in your application. We're going to progress and deliver the drag and drop functionality, which is in the proposal stage right now. We're looking at how the API is going to work. And I hinted with the text work that is being delivered right now, we're going to be able to progress further with internationalization, and in that we need to deliver translation support into the toolkit so that any user presented strings translate automatically, and that you will be able to make use of this same functionality to translate the content of your application. Also, part of helping people to understand their applications better, we're going to add some features and options for layout debugging, which I'll talk a little bit more about, and some render optimizations that are going to help speed things up in various different ways. So let's actually just start there, looking at the type of optimizations we're looking at. So first of all, we're moving more of the graphical objects onto hardware acceleration. So things that might be drawn partly on the CPU or in memory and then translated as textures, we're moving into actual rendering on your GPU, which will help speed up every application, hopefully by noticeable amount. We are, along with the text work, improving the caching and the text rendering. The main difference here, as well as the new shaping, is to make sure that the caching is at the right level, so it's not a full line of text, but also it's not just a character. The character level doesn't work with complicated strings, and a full line of text very rarely hits a memory cache or a texture cache, of course. So we're going to be tweaking that to get the right level and set it so that the performance is great and the memory usage is lower than it currently is as well. And we're looking to introduce more types to the objects that can be drawn, such as rounded rectangle, which is illustrated thanks very much to Renlight, who has been doing a lot of work here, and Cedric for his help in this area to help bring the curved edges and the more complex shapes to your Fyne applications. We're still working on finalizing an API on that and also optimizing the delivery, because this, as you can see, becomes quite complex when you start with transparencies and overlays. So there's a little more work there to do, but we're very excited that that's going to be in the release after the one that we're currently working on. As always, we are marching forward to try and support new devices, essentially always looking to be the toolkit that will work so that your applications can appear on anything that has a screen, basically. We are firstly looking at introducing support for Linux mobile devices. These are somewhat underway. You can try it out on the current version actually, but it's not fully there. We want it to be a first-class citizen. So PinePhone is the forerunner in this area that we're looking at right now. Librem is another option, and also we have been looking at the Planet devices such as the Cosmo and the Gemini. They are all sadly quite different in how they work. However, the underlying technologies should be straightforward, so we will be able to get applications there in a full screen kiosk mode, but integrating with the user flow and task switching and so forth. Maybe some more work, but those are the next devices that we're looking to be fully supporting. And actually, in part of that is to complete the Wayland driver support for Linux. If Wayland doesn't mean anything to you, that's great. And in fact, folk with a Wayland Linux desktop might find that their code has been working already. But this is broadly due to an X11 compatibility layer, which works very well, but we'd rather that we could avoid for performance and, again, integration level reasons. So we're going to be completing that driver and give it a more first-class experience to the more modern and embedded Linux desktop mobile experiences. And also more wide support for embedded devices like kiosks, screens that you might see, anything that is a graphical presentation but not on a typical device that you're working with. It might be your multimedia center in your house, or maybe even your thermostat. Items like that are going to be very interesting to see how we can continue the same smooth tooling and APIs to work on those devices as well. And lastly, for platform support, the web driver, which you can use already, we've talked about earlier today, does have some small limitations around multiple windows and storage functionality. Of course, with all of the work that we're doing in cloud storage, it's an ideal time to complete that. So we're going to make sure that the web driver is fully functional for that future release as well. Next, I want to talk a little bit about internationalization. This is something that we have been wanting to get into the toolkit for a very long time. We get an amazing number of people who are using Fyne in places that the languages don't support by default and the documentation isn't written in. And so we want to do more to support these so we want to make sure that more is done to support these languages that aren't bundled by default. We know that Chinese and Japanese are really popular languages that are missing. There's of course others that we would like to include. Do let us know which one you feel needs work for your project, and we'll see if we can prioritize that. Based on the text handling improvements, that should be much improved. But to completely deliver on it, we do need to add some more code around font lookups, so we can make use of any fonts that might be on the installed system, so that we can avoid bundling lots more data, and also to do more to understand the device's locale where the application is running to match expectations, whether it's date formats, languages, fonts, that kind of thing. And we want to make sure that we expose an API for application developers as well, to be able to make appropriate decisions based on the configuration that's found from the, again, locale, the language, the date format, and so forth. And the translation work that we're going to be delivering will be exposing to application developers as well, so that you can bundle assets that will adapt your application to the appropriate language found at runtime. We're also going to be working on ways that you can learn more about the widget tree in your application, so that you can query and understand how things are set up in your user interface, but also at runtime to be able to inspect the widget state, the geometry, the placement, and how it's interacting with elements around it, leading to a complete debugging of layout, which is really going to help people who are trying to choose the right layout, the right container, or they're not too sure why something is too small or too large. We're going to be able to deliver this debugging mode so that that is graphically presented to you for easier understanding. And for other use cases, we're looking to make it possible to store the user interface definition out to a file. So whatever is currently running or is being configured through code, we can think of a number of reasons why it might be interesting to write that to a file, much like the test handling we saw earlier, where you can compare the widget state with a file store representing exactly that information. But more powerfully, that you could then load that definition at runtime. Now, this has actually limited use intentionally. We're not expecting that you would move to developing your application in JSON files and load it at runtime. That doesn't really provide the same safety and compile checking that is available in the current tooling, but it does support some use cases that are not currently possible. Outside of the API and the toolkit, we're looking to bring a lot more polish and care to the application and add-ons listing websites. We're going to give them a spruce up, a new design, make something that really represents the quality of the software and the toolkit that's being presented in these sites. Of course, if you're not familiar, we have the apps site at apps.fyne.io and the more recently added component site, addons.fyne.io. And we want to make it much easier to find what you're looking for and also to manage the applications and components that you have listed on there before. And based off some of the work that you've seen earlier today, we're going to be working to distribute binary applications. So that means we don't need people to be having all of the download of source code processing each time they press on the install. And on top of this, the app discovery app that we have created, it currently integrates with that site. It discovers the applications and allows you to download them. But we are looking to have that make use of binary distribution as well. So when you tap install, it's able to just grab the binary for your application signed and ready to go, which means it's not going to need any developer tools present to be able to do that. Of course, makes it available for a wider range of platforms and also improve what its capability is for managing your installed applications and the upgrade process. Lastly, we are very excited to put more time into welcoming new contributors. It's been a great late part of the year. Oktoberfest has been a real boost to the number of people involved in the project. So thanks for everybody who's either found us or started contributing to the project just recently. We're really excited to have people working on design enhancements, different ways to improve the overall user experience and just make it a much better experience right out of the box, as great as it can be. There is a focus on stability as well, so most people are coming in and finding that they can fix a bug that was annoying them from their application, which of course benefits everybody. And a number of people also coming in from fixing the documentation, helping improve our examples, tutorials, the API documentation, all of which of course is open source and generated directly from the repositories that you can find on GitHub. But mostly, I am just super excited to be welcoming so many people to the community that are being involved in open source for the first time, whether it's because you're just starting development, building a graphical application, or finding that you want to give back for the first time ever. It's really great to have new people here, and I think you'll find that the whole Go community and also the Fyne community is really happy to help out, answer questions and offer support to people who are here and learning and trying to give back for the first time. So if you're considering it, please do get involved. I hope that these videos have all been educational, but if you would like to know more, We have so much documentation out there, examples, tutorials, all hosted on the developer.fyne.io website. We also have a YouTube channel, which I suspect you found if you're watching this video, but there are all of our previous conference videos are available there, and tutorials, everything from getting started to adding complex functionality to some of your applications. If you haven't found out how to contribute, then the place to go is GitHub. We're looking for more people all the time to help as part of the team that deliver the code, the tests. If you want to test or write tests, all great. Documentation, design, or if you just would like to come along and offer some positive vibes, or even a carefully worded critique of something that you think could be improved, everything is very welcome. And of course, I've mentioned it earlier, we are hugely thankful to all of our sponsors that make this possible. If you like what you've seen, if you get a lot of value from Fyne, then please do consider sponsoring the community. It just would not be possible without that. We really appreciate it, and very much looking forward to hopefully inviting speakers to collaborate in person next year. And of course, a sponsorship really helps us to get people traveling and able to come together. So thanks in advance if you would like to do that. It's been fantastic to present another packed event of all of these talks. Thank you so much to all of our speakers. It's been really great to get your thoughts. Thanks to Jacob, to Derek, to Cedric, and to everybody who has been part of making it possible. I know a lot of names have been shouted out from various slides during the course of the day, so thanks to everybody involved. Hopefully we will see you next year, wherever or whatever we're doing. It will be live streamed again, so do come back and look out for information next year when we'll be setting up another stream. But if you have other questions, anything that's come up today, or something that you would just like to discuss with the team, please do consider joining us for our Q&A with the various members of the community. We will be convening on Jitsi at the URL on the slide there in just a few minutes. I know that we're a little bit ahead of schedule wrapping up, but I'm sure that you'll find people in there shortly. I will be there for roughly an hour. Whatever time zone that is, we hope that you'll join us for a chat or a question, and look forward to speaking to you all there. Thank you so much, and enjoy the rest of your day.